Hello and welcome to this new tutorial. In this tutorial, we are going to see how we can perform shape matching using Emgu CV. So in this tutorial, what actually we want to do is we will select an image. Let's say this is my source image and there are some different signs. And then we perform, when we click on the shape matching, we need to select a target image that which we actually want to compare, or based on the shape we want to compare and find which one we find here. So when we apply, you can see the similar images have been found. But if we increase this threshold, let's say a little bit further, and then when I click on apply, you can see that the image with the same match has been found. So with the same shape has been found. Even though if we do some rotation, still we are able to find the match based on the shape. So we will learn how we can do this in this tutorial. In my previous video, I created this project and configured it to use Emgu CV 4.5.1. If you do not know how to configure it, you can check my previous video. So the first thing that I'm going to do is to add a menu item into this menu strip. So I'm just going to its properties, into the collection. You can add one more tool strip menu item. So click on add and let's give it the text as the process. And inside this process, in the drop down items, I just want to add a submenu inside it. So I'm going to click on that and let me give a text shape matching. And the ID will be the same as shape matching. Okay, and click on OK. And to define a click event for that, I'm just going to select that menu item. Its name was shape matching, and from the events I click on this click event 2 times, and then this is the event that is going to call when we click on the menu items shape match menu. And write it here a try catch block so I can avoid any errors. And one more thing that I want to do, in the last time I created this event to read the image and display it. In fact, since we are using the images, the selected images in different events, so I'm going to create a dictionary item inside this class so that I can share the images with other methods within this class. So we can create a dictionary item, dictionary, and this one will be the strings, and the key will be the strings. So indexing will be done using this string, and the value will be the images that I read it. So I call them BGR, and those will be of type byte. Okay, and we can give it a name, IMG. You can write it IMG dict, so dictionary. The first thing that I need to do is, in order to use it in the constructor, I can create its object. So I just call it IMG dict. Okay, and this constructor, using the default constructor, we created the object so that we can use it. So once I read the image, I can put those images inside this image dict. So after displaying it, image dict dot add, and here we need to provide a key string. So I'm writing it input as my key. So whatever the input image I have, I'm going to add it, and the image will be IMG. Okay, but one thing we need to make sure that if we read first time image, there will be no problem. But if we read the image again, then with the same key we cannot insert it or add it into dictionary. So what I will do is to check if there is any image img dict dot contains key with the same key if already exists, then we can remove that input If it exists, then imgdict dot remove, we can remove that and provide this input. So any image that already exists, I will remove it in case if it already exists with this key, and then I'm adding the new image into this dictionary. Okay, so when I click on the item shape underscore match, then I want to perform the shape matching. So in fact, instead of writing the code here, I can create a new method and call it private void apply shape matching, and we can write it try catch, and here we can do a throw exception, also throw new exception, and we can say ex dot whatever the message it is, we will throw it. So I will be calling this method from here. Okay, and since for matching, we have a method in the Emgu CV, so we can see match shapes open CV. We can see if there is an example. So when you see these, basically there is a method that is what we call it the match shapes, and it is expecting the contours of both the images that, or both the shapes that we are going to match, and then it also needs a threshold value that we want to compare. So what we need to do is we need to find the contours for the both input image and our target image, and then we give it to the match shape function. So this is what exactly I'm going to do. Okay, so what we will do actually when we are comparing two shapes, then we will be using this match shape method, which actually expects two contours. So we will provide two contours and then a threshold, that is the distance, what we are going to accept this distance to be the shapes we consider to be matching. So I need to customize this method, and we can create a threshold, for example double threshold, that what we want, let's say I set it at 0.01. so inside this apply shape matching, I need to read the image from my dictionary which I created, imgdict, and we must have this using the key input, so which is the original image. That let me clone it, but before that I think we should check if the dictionary has this value or not. So imgdict and this input dictionary equals null, then we can basically throw a message, an error exception, throw new exception, that select an image. Okay, if it is not, then we can read that, and I just clone it so that I just copy it. I don't want to change the original image, and we can call it img. We can do something with it actually. What we can do is img dot, we don't need this one in the color, so I'm just going to convert it. In fact, img, let me call it source is equal to img dot convert, and I want to convert it into a grayscale image, keeping the depth same as the original image. Next, I can do, in order to see if there is some error, we can use the Gaussian blur with a 3x3 window. And what else I want to do is we can apply a thresholding here, threshold binary. And in fact, if I show the image that I want to process, that this is the original image, and you can see the background is white, so I need to use the inverse threshold. Okay, so I'm going to use a new gray, and let's say it's very bright, so threshold minimum to be 240, and we want to replace it with 255, and that's it. In fact, smooth, that's a Gaussian. Okay, so this is for the original image. And by the way, we also need a target image. So this is the image that I'm going to search. I mean, for example, I'm going to search for a shape like this one. So I need to read this image as well. So let me do something easier now to stop. I can read this image just for testing. Later we can update it. I can do one thing, image bgr byte, and we can call it img template is equal to new img template, and then we can read that. I need to put an @ so that the escape sequences will not be utilized, and we can pass it as an argument here into this method. So img template, and just keep the next value as it is. So we have to read this image as it is. So I'm just going to write it here as a parameter in this apply shape. So we are going to provide a template. Okay, so that template is also basically a BGR image. We also need to do the same thing as we did here. So I'm just going to copy this one, and we do the same thing for the target. Let me call it target is equal to img template dot convert. We will first convert it, Gaussian smoothing, and all those stuff. Okay, so the next thing that we need, if we want to apply this mesh shape, then we need the contours. So we need to find the contours for both the images. So instead of writing the code again and again, one thing that I can do is to create basically a new method here. So I can reuse it, private, and this one will return vector of point. By the way, this vector of points, I think of should be capital, since I did not use the one of the utilities. So this is vector of this is present in using emgu.cv.util. So this is what we should also include in our using statement here. So this class is present in date namespace. So we are going to return the vector of vector, and we can call the method as calculate contours, and we can pass in a grayscale image. So image bgr comma byte, and we can call it img. And one more thing that we can customize this method, by the way. So let me write it that try and try exception. If we have any exception, throw new exception ex.message. Okay, so this one will return the vector of points, that is the contours that we will get, and it will return it. So what I can do is we can create a vector of point, we call them contours, is equal to new vector of points. Okay, and for hierarchy information also, since the contour find contour method also needs it, so I'm going to create a new mate object, although we are not going to use it. And then using cv invoke dot find contours, we can find the contours of this image. So this is the image for which we want the contours, and where we want to put the output of these contours is in this contours object. The hierarchy will be stored in the h object, and the retrieval type that we are going to do is we are interested in only the external contours. And the chain approximation that we want to do is we want to make them as simple as possible. Instead of returning all the possible contours. We just need the simple contours as we need. So instead of, for example, just like for rectangle, instead of returning all the points around the boundary, it will return only 4 points, because if we use those 4 corners, then that is enough to construct a rectangle. Okay, and then we can return the contours back. One more thing I think we should do is to filter the contours. If we look at the original image, for example, we need the contours for these images, but it will also generate contours for these characters. So we may need to apply a threshold to remove the contours that are smaller than certain area, whose area is smaller than certain threshold. So I can update that. So the easiest way will be to take a parameter, let's say double, let me call it threshold area, and let's say we initialize it to 10,000. So we are interested in the contours whose area is greater than 1,000. So let me create another vector of points, and we call it temp contours or filtered contours is equal to new. We need to create a new object of it, and then we can loop through all the contours one by one. For I is equal to 0 to contours dot size. Okay, and then I need to calculate the area of the contour. So let me call it area is equal to CV invoke dot contour area, and this is expecting a contour object, so we can provide this contours ith contour, and then it will calculate this area. And if this area is greater than or equal to our threshold area, then we will consider it. So I'm going to copy it, filtered contours dot push, and we need to push the contours ith contours into this one. So we filtered the contours according to the area, so all the contours greater than this area will be added, and instead of this one we now need to return the filtered contours. Okay, now we can use this method to calculate the contours for both the images. So I'm going to call this method in our click method. So variable img contours, source image contours, img source, let me say contours is equal to, let me call this method, and it is expecting our image. So img source, I'm going to send the source image, and also in fact it should be a gray, not a BGR image, so I'm going to make it a gray image. Okay, and we can do the same thing for img target contours. Let me change the spelling also, and we can call the same method again, calculate contours, and we can give image target. Okay, so we will get the contours for both our target image and also the source image, and once we get those contours, it's time to compare them. The first thing that I will make sure that if img source dot size equals 0 or img target dot size equals 0. Now I just want to make sure that my source contours dot size should contain at least one contour, one contour to compare, and also my target contours dot size should also be greater than 0. But if both of them, any of them is equal to 0, then it means I cannot compare them. Then we can throw new exception and say here that no contours not enough contours. Just gives us a message to clarify that there are no contours. If there is no any problem, so we have contours, more than one contour in both of them, or at least one contour in both of them, then we can loop through those contours. So we can call them img source contours dot size. I'm looping through all the contours in my source image and comparing it with my target. I am assuming that my target has only one contour, or if this image, let's say this is my target image, if there are more than one contour, then at least we can also select the biggest contour. We can find the biggest contour as well. We will write a method. So only biggest contour ID will be returned. So when I'm looping through the contours, and then I'm going to find the distance. So variable distance is equal to CV invoke dot match shapes. Okay, it is just like template, but we are now matching the shapes. So I'm going this image source contours ith contour and comparing it with the target contour. img target contours, and this is just the zeroth. I'm assuming that the zeroth one is the biggest one and the highest one. We can also check it, and we can write a method to select the biggest contour as well, so it's not a big problem. And one more thing, that contours match type dot, there are three methods, the L1, L2 and L3. This is the how the distance is calculated. As you can see here, the formulas, which one is working fine, it depends on which one is better, but let me select with this sum of square distances. So I'm just selecting the L2. You can explore with the others as well, but the way they are working is similar. So once we find the distance between two, we can did we define a threshold for that one? Yes. Okay, so if this threshold is greater than, if this distance is less than or equal to threshold that we defined, that it means that we can accept two contours if their distance is close, that is less than our threshold, then we can say that the both shapes are similar. So what I can do is I want to draw a bounding box around it. So let me say rect, I want to create a rectangle, cv invoke dot bounding rectangle, and I want to get a bounding rectangle around my source image object. So this using this one, and I want to draw it over there. So img target, not target, it is img source dot draw. I'm going to draw a rectangle, and then we can give a color new. If I convert it into gray, then I should use this img directly instead. So img dot rectangle new bgr, and we can draw it in blue is 0, in a green color, and as red is also 0, and we can make a little width a little higher. Okay, so we just draw the image, and if we want, we can also put some text around the how much was the distance actually. So we can write this put text, and we want to draw it on this image, and we can show the distance dot to string. And remember that this 2 is basically a float, so we can pass this format argument, that f means it's a float with 6 decimal points, up to maximum 6 decimal points. And where I want to draw it is, we need to show a point where we would like to draw it, is the rectangle dot whatever the x location it has, and rectangle dot the y point. So this one will be the my point where we will draw the text, and also maybe we can write a little bit, push it down so that it should not be exactly on the rectangle. line. In fact, we can do a 20, for example. And it also needs this font face. So font face dot, we can use the plain, it doesn't matter, whichever plain, and we want to use a scale of, let's say, 4 to make it a little bit bigger. Or is it too much? Let me do it 3. And then we can give a color. So new scalar, MCV scalar, and it should be blue, and maybe red, doesn't matter, whichever color you want to select. So I just draw the text around the location, the distance, what was the distance, just to show it. Okay, so once we do these things, and then we can show the in the picture box dot image our newly drawn images. So dot to bitmap. Okay, so that's it. So we calculate the shape and then we find the distance, and then using the threshold we did it. Let us try if it is working with the default template or not. Okay, so we can open an image, and my source image will be the one traffic signs. So this is the image. Okay, and the sign that I want to check is shape matching. So now you can see that this was the shape actually. Let me show you. I think I cropped this one. Yes, this is the default sign that I just read to search for it and to match using the shape we wanted to match. And with the default, it says that it is matching with this one, not with these one, but the ones which are just like circular ones. It is matching with them, not this one. So you can see that, and this is the distance it shows. And also when you see with the stop, it is 0 almost. So if I reduce the threshold value, which I use basically 0.00, so let's say 0.0001, let's say a smaller value. Let's see if it works fine or not. So I need to restart the application again and do the same process again. Okay, so now we have this one in the shape matching. Now when you see here that it matched with only exactly this one. So the shape matching is working, but none others has been selected. So it's good. But one thing that you realize, when I need to change the threshold and all those parameters, I hate to go and rerun the code, which actually I don't want. So that is what the beauty of the .NET or this Windows Forms, that I want to control everything from here. So maybe we can create another form, and then we can control those threshold values and change them. So I will do that one also. And when my form starts, initially it starts with this position, I mean this size. I want to be in the maximize mode. So two things I will do. And what I want to do is, first of all, to start your form with the maximized mode. In the properties, we can set, instead of Windows normal, we can make it maximized. That's it. And secondly, in order to change these parameters and see the results, I can add another form, and from there we can select the image which we want. Instead of here, you can see that I did from here, I am selecting it hard-codedly. So instead of doing it from here, what we can do,